All right, it is ready. Or it is ready. It is time for 5.2 number 3. Now, when we left off at 5.2 number 2, we had figured out how fast your pet would be going if you put 4,200 joules into it as kinetic energy. Now, I've told you before, this number actually does have an importance to it, which we're going to learn about later. That's why I'm using it. But now, okay, we figured out how fast it was going. Figured out in this case, being a chicken, it was going about 100 miles an hour. But now, what would happen if we took the chicken's velocity and turned it around and put it, sent it ballistic, straight up. Chickens away. So there we go. There's your chicken. And there's your chicken, and there goes his feet. Feet. Okay, up you go. Ballistic chicken experiment. How high will it go? Now, guys, we don't have any formulas for that yet, this chapter, do we? Not saying they're not coming, just saying we don't have them now. But we do have formulas we've used in the past to determine things like that. So we're trying to figure out how high it's going to go. Which means, well, what do we know? We know, initially, our initial velocity is equal to 51 meters per second. Now, when it gets to its highest point, it's going to stop. So that's when it basically rises. It can't rise anymore and start right before it comes down. So we know the final velocity is going to equal 0. Now, as a person who's lived on Earth, I expect you all to know that acceleration due to gravity is going to equal negative, if we're positive is up, then it's going to be negative 9.8 meters per second squared. And we're trying to find how high it will go. That's the big question mark. So we got 4 formulas left over from chapter 2. And let's see if we can use it. Now, by the way, your notes probably have them as delta x. The same thing with delta y. So we got this one. Delta y is equal to 1/2 your final initial velocity plus your final velocity, delta t. Now we're trying to find this. We do know this. We don't know how long we've been up there. We don't know the time, so can't use that formula. Your final velocity is equal to acceleration, your initial, that's supposed to be initial velocity. Sorry, that was not supposed to be like that. It's supposed to actually be this. We do know the initial velocity, we know acceleration. We could find the time, and then we could use the time to find this one. We could do that. Might take a while. Let's see if we can find a better one. Oh, we can use this one. Here's delta y. That's what we're looking for. Initial velocity, we got that. We got acceleration. We could take the time and put it in, but again, that's a 2-step. It's a lot of extra steps. But what about this one? Final velocity, initial velocity, acceleration, and that's what we're looking for. Got it. That's what we're doing. Okay, so going over here, v final velocity squared is equal to the initial velocity squared plus 2a delta y. We're going to find delta y. We're going to find delta y. So, final velocity. When you get to the highest point, you have no more. For a split second, you have 0 velocity. Initial velocity is 51 meters per second, and that is squared. Plus 2 times negative 9.8 meters per second squared times delta y. That's what we're trying to find here. Let's start working with this. Okay, now 0 squared is 0. Now 51 squared, by the way, remember how did we get that 51? We took the square root of that, didn't we? Well, this squared should be that. So 2, 6, 2, 5. Save yourself some button pushing. Plus, 2 times a negative, that'd be minus 19.6. Now, by the way, this is meters squared per second squared, and this is meters per second squared times delta y. subtract 2,625 meters squared per second squared. And then over here on this side, do the same thing, 2,625 meters squared per second squared. So that's gone. And we end up with negative 2,625 meters squared per second squared is equal to negative 19.6 meters per second squared. Notice meters are squared here, but they're not squared there. Delta y, going to continue this. Divide both sides by negative 19.6 meters per second squared. Negative 19.6 meters per second squared. Now, that's that. Cancel, cancel, right? And you end up with delta y. Now, the negatives are going to cancel, right? Also, second squared, going to cancel second squared. Meters, well, this is meters squared, so that's meters times meter. We can take out that squared. So our answer is just going to be meters. And I actually did that. I can't use my calculator right now because I'm using it to film. But our answer was 133.9 meters. Now, again, 9.8. We only have 2 sig figs. So our final answer is going to be 130 meters upward, of course. And that's our delta y. Pretty high when you think about it. 130 meters is approximately 400 feet up, about the height of a 40-story building. Pretty impressive when you think about that. Good thing is chickens rarely fall to their death. They can't really fly, but they can kind of flutter down. I think the chicken will be okay. Now, a couple words to talk to you about with your math. If you have a bigger animal than me, chances are it wasn't going as fast. If it wasn't going as fast, it's not going to take as long for acceleration due to gravity to bring it to a stop. So if you had a bigger animal than me, probably not going to go as high. If you have a smaller animal than me, it's probably going to go higher. Other than that, these are actually fairly reasonable numbers. Remember, 4,280 or 4,200, that's a fair number of joules. Anyway, I just thought I'd let you know. There you go.